All right, let's talk about something that is absolutely critical if you're studying for the ARE exams, condensation. Now, I know it might seem like a minor thing, right? A little bit of water on a window, but trust me, it's a silent threat, a hidden enemy that can seriously mess up the health and safety of your buildings. So let's break down how we, as architects, can defeat it. So have you ever really stopped to think about why our buildings sweat? You know what I'm talking about? You see those little water droplets forming on a cold pipe or a window pane, and it's easy to just ignore it. But that moisture, it's not just water. It's a symptom, a huge red flag of a much larger process happening inside your walls. This sweating is condensation, and understanding it is completely non-negotiable if you want to design buildings that last.
And the stakes here are incredibly high. Seriously. Uncontrolled condensation isn't just a cosmetic issue. It is a destructive force. It's the perfect breeding ground for mold and mildew, which, as you know, can cause huge health problems for occupants. It literally rots wood framing and corrodes steel, attacking the very skeleton of your building. Left unchecked, this can lead to catastrophic failure of the entire building envelope.
Okay, so if we're going to defeat this enemy, we have to understand its secret weapon. And that weapon, the core scientific principle behind this whole mess, is something called the dew point. This right here, this is the key that unlocks everything about condensation. So, what in the world is the dew point? Well, put simply, it's the exact temperature where the air just can't hold any more water vapor. It's reached its limit. Think of the air like a sponge that's soaking up invisible moisture. The dew point is the temperature at which that sponge becomes completely waterlogged and has no choice but to start dripping out liquid water. You've seen this a million times. The perfect example is your car window fogging up on a cold day. The air inside your car is warm and humid, right? It's full of moisture from you just breathing. As soon as that warm, moist air hits the cold surface of the window, the air right next to the glass instantly cools down to its dew point, and bam, liquid water, fog, appears all over the glass. It's the exact same principle at work on our buildings. And that brings us to what is, without a doubt, the most important thing you need to remember for your PPD and PDD exams. There is one simple, powerful golden rule that governs all condensation. If you can burn this one thing into your brain, you are well on your way to mastering this topic. So here it is, the unbreakable law of condensation. It will happen if and only if the temperature of any surface is colder than the dew point temperature of the air that's touching it. That's it. Let me say it again. Surface temperature is less than the dew point temperature. It's a fundamental law of physics, and it always holds true. Okay, let's make this real. We're going to walk through a quick practical example so this really clicks. Imagine you're in a room. It's a pretty comfortable 21 degrees Celsius, about 70 Fahrenheit, and the relative humidity is sitting at 40%. Pretty standard indoor conditions. Now for air with those specific properties, 21 degrees and 40% humidity, we can calculate that its dew point is right around 7 degrees Celsius. Okay? So that is our magic number. That is the temperature threshold that we absolutely cannot cross. Now, let's say over in the corner, there's a poorly insulated section of an exterior wall. Because it's cold outside, the inside surface of that wall has dropped to a chilly 5 degrees Celsius. You see where this is going, right? Exactly. The surface temperature, 5 degrees, is less than the air's dew point temperature, which was 7 degrees. The golden rule has been broken, and the result is inevitable. Water droplets are going to start forming on that wall. It is truly that simple and that predictable. Now here's the beautiful part. Understanding this rule doesn't just show us the problem, it also points us directly to the solution. I mean, think about it. Since the formula only has two main parts, surface temperature and dew point, that means there are only two ways for us to win this fight. It boils down to two and only two choices for us as architects. Strategy 1, we can raise the surface temperature, making it warmer than the dew point. Or strategy 2, we can lower the air's dew point, making it colder than the surface temperature. That's it. Every single solution to condensation you can think of falls into one of these two buckets. So how do we actually do this? Let's open up our architectural toolkit and see how we put these two big strategies into practice. How do we as designers actually make this happen in the real world to create dry, healthy buildings? Okay, here's how it all breaks down. To raise that surface temperature, our main moves are 1.
increasing insulation, and I'm talking especially about continuous exterior insulation to get rid of those pesky thermal bridges. And 2, improving airflow across cold surfaces. Think baseboard heaters or even just telling clients not to shove furniture right up against an exterior wall. Now, to lower the dew point, the goal is simple: lower the humidity. And we do that with things like ventilation, exhaust fans, and of course, dehumidifiers. Let's just zoom in on that second strategy for a minute: lowering the dew point. The best way to do that is to get water vapor out of the air. So, number 1, you ventilate, swapping that moist indoor air for drier outdoor air. Number 2, you have to be aggressive about exhausting moisture right at the source. That means always running the fan when you're cooking or showering. And finally, you have to manage all the other little moisture sources, like having too many houseplants or always drying laundry inside.
All right, let's bring it all home. For everybody out there studying for PPD and PDD, this is your final review. We're going to boil this all down to the absolute must-know essentials. This is the bottom line.
Okay, here we go. Number 1, you have to know the golden rule cold. Surface temp less than dew point equals condensation, period. Number 2, to raise surface temps, your go-to tools are continuous insulation and getting rid of thermal bridges. Number 3, to lower the dew point, your target is an indoor relative humidity somewhere between 30 and 50%. And you get there with ventilation. And one last super important point, especially for cold climates, you have to be incredibly careful about where you locate your vapor retarder in the wall assembly to keep the whole thing dry.
So, I'll leave you with this question, because this isn't just a physics problem to memorize for an exam. It's a fundamental design challenge. Now that you truly understand the rule, the real work begins. How are you going to apply these principles to design buildings that are smarter, that are healthier, and that are way more resilient? Buildings that are designed from day one to never, ever break that golden rule.